Welcome back to another section of Uncle Sam online tutorial. Remember, before you do any other thing, to please subscribe to my YouTube channel and also follow me on all my social media handles for more videos. Okay, in today's class we are going to be considering dimension. Now this is a physics topic and it's very fundamental, very important. So what are dimensions? Dimensions are the various parameters that are embedded in a particular quantity. All right, now how do we now get dimensions? Dimensions are gotten from, in derivation, it is gotten from the first letters of all the fundamental quantities that we have. For example, the fundamental quantities that we have are mass, length, time, temperature, and so on and so forth. So these are the ones that are very much rampant in what? Considering dimension. So how do you now get the dimensions from these? I thought it's the first letter. So for mass, we're going to be using just M to denote anything that has mass in it. Any quantity that has mass in it, we are using M. So length, we are using L. Time, we are using T. And temperature, we are using Kelvin. Yeah, we are using Kelvin for temperature. So that being said, let us now consider the different dimensions of some derived units. Okay, we can start from some fundamental units. These are the dimension of fundamental units. So for mass, the dimension of mass is M. So dimension is basically used for derived unit. So we're going to dive into that now. Okay, follow me. So we are going to first of all write out the quantity that we are considering. After writing out the quantity, we write out the formula that makes up that quantity. Then we'll go over to writing out the units. Then lastly, the dimension. Let me make this line a little bit bigger. The dimension. Yes. Yeah. So let's continue. So the first quantity that we're going to consider today is area. Now, what is the formula for area? Area is actually length times length. Yes, length times length. Now, this is basically for a square, so I'm using that as a standard. So what is now the unit? Unit of every area, the SI unit mostly, is actually m squared. Okay? Now, that is meter squared. Now, how do you now write the dimension? Since everything that represents length, whether width or height or breadth, it is still a length, just that the different positions are, they have different positions. So they are still basically length. So what you're going to do is, since length stands for, the unit of length is m. So we're going to be using m to denote what? The dimension. So since m here has square, that means the dimension of area will still have square. So it's going to be L squared. Okay? That is the dimension for what? Area. So next up on our list is what? Volume. Volume. Volume, the formula for volume is actually length times length times length, or length times width times height. Whichever one, they are still the same thing. So far, it is what? It's a distance from one point to another. Whether vertical, it is still length. The reason why you call it height is vertical position, but it's still length. The height is length in a vertical position. So let's continue. The unit is what? Meter cube. Then the dimension is going to be what? L raised to the power of 3. Okay? That being said, we go over to what we call speed. What is speed? The formula for speed is distance all over time. Now, what is the unit of distance? It's still meter. So the unit is meter. The unit of time is also what? Second. So the SI unit of speed is meter per second. How do we now represent that in dimension form? M will start for what? L, which is length in dimension. Then S will stand for what? You guess right, T. So it's going to be what? L/T. Otherwise written as LT to the power of -1. So that is another way to write it. We'll go over to the next one, which is same thing as velocity. I hope you know that speed and velocity are the same thing. So I'm just going to write the same thing that I did here. Just that velocity is displacement, the rate of change of displacement with respect to time. So the dimension, the unit of displacement is still meters. The unit of time is what? Second. So the unit of velocity is still meter per second. and the dimension will still be L slash T, okay, or LT to the power of -1. Why? Because anything over is negative, is inverse, okay. So the next one on our list is acceleration. Acceleration. What is acceleration? The rate of change of what? Velocity with respect to what? Time. So acceleration is what? Velocity, the formula, over time. Now, what is the unit of velocity, Ron? The unit of velocity is meter per second. So the unit of time, joining it together, you're going to have something like meters per second squared. How do you now represent it in dimension? It's going to be M will represent L, and slash S square will represent what? T square. Or you write it as LT to the power of -2. I hope you are following. Now I'm going to clean that off and go over to the next ones. Okay? So I'm going to clean that off. Pardon me for doing that. I'm going to clean that off. I hope you got that. So I'm still continuing with the quantity here. Quantity, formula, unit, and dimension. So we're going over to the next one on our list. Now, we have treated a number of them. The next one on our list is what? Energy. Energy is the ability or capacity to do work. And in this case, I'm just going to use the basic formula of potential energy because it's still the same. Both of them have the same unit. So the formula is going to be mgh. So mass times gravity times acceleration. What is now the unit? The unit is going to be what? Kilogram meter square per second square. That is unit of what? The SI unit. Remember, everything I'm calibrating under the units are the basic SI unit. So the basic SI unit of energy is kilogram meter square per second square. Okay? So let's transcribe that into dimension. kg will now introduce mass, which is m. So we have m. Then meter square will be what? L squared. Then slash T squared. Otherwise, you can write it as m L squared T to the power of -2. Okay? So we'll go over to the next one, which is what? Work. Work, the formula for work is force times distance. Yes, because work is said to be done whenever a force applied to a body. Remember what I said about a body. A body can literally mean anything. This marker can also be named a body. So work is said to be done when a force applied to a particular body causes this body to move, and not just to move in the direction of the force that is being applied to it. So it still has the same basic SI unit of what? As same as energy. So it's going to be kilogram meter squared per second squared. So it still has the same dimension, which is m L squared slash T squared, or m L squared T to the power of -2. So I'm going to clean that off, this remaining one, so I can be able to fill up other ones. Okay. Now, so we're writing the one of work. So the next one we're going to write now is force. Yeah, let us also consider force. What is force? Force is product of what? Mass times what? Acceleration. So what is mass? The unit is going to be kilogram meter per second square. Yeah, that is the basic SI unit of force. So the dimension is going to be what? kg will represent m. Then m here, which is for length, will represent L. Sorry, this is m, L. Then slash T squared, or better still written as m L T to the power of -2. Slash T squared is something as T to the power of -2. Okay, now the next one on our list is actually what? Pressure. Pressure is force. The formula is force over area. Force over area. So what is the basic SI unit? The basic SI unit is going to be kg per meter per second square. That is the basic SI unit of what? Pressure. So now let's transcribe it into the dimension. It's going to be m slash L slash T squared, or better still written as m L to the power of -1, then t to the power of -2. So what next we have? We also have some other quantities, something like linear momentum. The basic formula is mass times velocity. Mass times velocity. So the basic SI unit is going to be kilogram meter per second joules. So the dimension is now going to be kg represent mole for mass, then m represents L for length, then slash T. Okay, so we're still on. I'm going to clean this and still continue because there are still more that I have to cover. I hope you are following. All right. Okay. So, that being said, so we'll go to the next one, which is what? Impulse. Impulse is also a quantity, a derived quantity. What is impulse? Impulse is force times time. So force times time. What is now the basic SI unit? It's going to be kilogram meter per second cube. So the dimension is going to be m representing kg. Then for the meter, L is used to represent that. Then slash t to the power of what? 3. Or otherwise written as mlt to the power of -3. I hope you're following. The next one on our list is power. Power. What is power? Power is actually the rate at which, time rate at which energy is being what? Expended. Okay? So power is actually energy or work done all over what? Time. The basic SI unit of work done is, or energy, because both have the same SI unit, is kilogram meter square per second square. Then if you're adding time to it, it's going to be kilogram meter squared per second squared. So that is the basic SI per second cube, sorry. That is the basic SI unit of what? Power. So if you transcribe it to dimension, it's going to give us m for kg, then m squared is represents length squared, then what? Slash s represents time, so it's t to the power of 3, or otherwise written as m L squared t to the power of -3. So that's where we're going to stop for today on dimensions. I hope you got a thing or two from what I just taught today. Remember what I said, we get dimensions from the basic what? SI unit, fundamental what? Fundamental units. We got them from there. As you can see, mass, length, time, temperature, they are what? Basic fundamental quantities that we have. And what? These calibrations, their first letters are used as the dimensions, okay? Because I told you that the derived quantities are gotten by a simple combination of what? Fundamental quantity. So all we did was just find the dimension, literally meaning find the parameters that are embedded in every of these quantities that we were listed on the board. Thank you for watching today's video. See you in the next class. Bye-bye.